So this is the rest of the review for chapter 11. We're on to finding for 33 and 34. We need to find the variance and the standard deviation. Now, you will be given this table and it will look exactly like this. This was finding it by hand. However, remember that I said if you need time on something else, do this on the calculator. This was plugging in your values, and then it would give you your X bar value, it'll give you your standard deviation. The variance is the only thing that that table won't give you. And remember that you can find the variance by squaring the standard deviation. So if you were looking on your calculator, this standard deviation or this square root value, because this is where your standard deviation is, if you were doing it by hand. That's your standard deviation value. Remember on the calculator, it's this sigma x notation is what they use. So that's the number that you would want for your standard deviation. So in this case, either way you choose to do it, you should get a variance of 14.6 and a standard deviation of 3.8. Now remember, this variance is this value squared. So this is 3.8 squared. It's your standard deviation squared for your variance. So you can either do it on the calculator or do it by hand. If you want to save time, because there are 39 problems, I would do it on the calculator. Does anyone need me to show you how to do that on the calculator? No. Okay. So then we have the normal distribution problems. And these are the ones that you probably had the most trouble with. Unfortunately, you're only going to be given the one curve, so you'll have to make use of just the one curve. And we're going to use that information for 35 and 36. So we're told that the mean is 650 and the standard deviation is 100. So we need to find the probability that a randomly selected exam has an exam score between 650 and 850. So we're told that the mean is 650. So on our chart, this is 650, right at our mean. And our standard deviation is 100. So we add 100, is 750 at one standard deviation. At two standard deviations, we're at 850. So we want to find the probability that a randomly selected exam has a score between 650 and 850. So that's between our mean and the second deviation. So we're looking for this area. And we found that area by adding this decimal and this decimal, because remember, we know that that's the area of this first deviation and this is the area of the second deviation. So we have 0.3413 plus 0.1359. And you end up with 0.4772. And it'll ask you probably to leave it like this, as this decimal. Now, in 36, it says if 350 people took the exam, or 300 people who took the exam are selected at random, about how many of them would you expect to have a score between 650 and 850? So we just found the probability of having a score between 650 and 850, right? That's that decimal that we just found. So we want to know out of 350 people, how many are in between that range. So that's where we take the 350 and we multiply by to 0.4772. We're multiplying by our probability. So when we multiply, we're going to get 167.02. But it's going to ask you for a whole number because it's asking for people, and you can't have 0.2 of a person. So it's going to be approximately 167 people. Any questions about that? The last three questions are all going to focus on the normal distribution curve with the decimals. So for 37, it asks the probability between negative 0.8 and 0 to the nearest 10,000. So if we went back to our curve, negative 0.8 is about here, and it wants to know from negative 0.8 to 0. So it wants to know this area right here. So remember from the table that the table gives you the area from 0 to that number, and it also goes in the reverse. These areas stay the same, but you can make these top numbers negative. So negative 0.8, the area to negative 0.8 is 0.2881. So this answer is just going to be 0.2881 from 0 to negative 0.8. Number 38 wants to know the probability of all the values greater than 1.4. So if we go back to our chart, 1.4 is going to be right about here. And it wants all the values greater than 1.4. So that's all of these values. Remember, you have that hang off after your third deviation that you don't know what percent is over there. So this is the problem where we're going to take that we know from the mean to the right is half of our information, and we want to find a portion of that information. So we're going to take 0.5 and subtract the part that we don't want. So we wanted everything greater than 1.4. So that means from 0 to 1.4 is the section that we don't want. So that is this 0.4192 number that's given to us in the table. So we're going to subtract 0.4192 from 0.5. When we subtract that, we're going to get 0.0808. And again, it'll probably ask you to leave it like that. And then 39. The scores on an exam are normally distributed with a mean of 67 and a standard deviation of 10. What percent of the scores are greater than 57? So this is where you're looking at your curve, and I'll actually draw one because I have enough room down here to draw one. We'll draw our standard normal curve, and we would have our mean, and in this case we're told that our mean is 67. Then we have 1 deviation, 2, and 3, and then the same thing in the opposite direction. And this time our standard deviation is 10. So going to the right, we're going to add 10, so we have 77, 87, 97. And then going to the left, we have 57, 47, 37. So we want to know what percent of the scores are greater than 57. So 57 is 1 deviation to the right, or to the left, sorry. So we're looking for the total area this way. So we're looking for that whole area. Remember that this is the mean. So this is where we're going to take from the mean to the right is 50% of our information, and we want to add this additional section. So that's gonna be our 0.5 plus, on our graph, that one whole deviation is that 0.3413. So we're gonna add 0.3413. When we add that, we're gonna get 0.8413. But it asks for a percent, so we wanna change this to a percent. And it's 84.13%. And again, depending on how they ask for your answer, make sure that you're putting your answer in the correct format. Any questions about the table, how to use it with those with the normal curve? All right, then we are done.